today we're going to be using our knowledge of the chain rule to do a new kind of differentiation. Sometimes there are times where you can't solve for y, and if you can't solve for y, you can't do the derivative like normal, but it turns out you can still find a formula for the derivative, the instantaneous rate of change of curves, even if you can't solve for y. We'll see that in just a second. And sometimes you can solve for y, and it's still more useful to do it this way. So let's start with a quick warm-up of things that you should be able to find the derivative with respect to x for. So what is the derivative with respect to x for each of these? And hopefully here we see this is just the derivative of x is 1. The derivative of 1 times 2 is still 2. This is a constant multiplier, and the derivative of a constant is 0, so we just get 2. The derivative of f of x is f prime of x. The derivative of sine of x is cosine of x. The derivative of sine of f of x. That's the first more challenging one, but we should know it. This is a composite function. F of x is inside of sine of x. So the chain rule says we do the derivative of the outside. So cosine of, and we leave the inside function alone, but we do multiply by the derivative of the inside function at the end. So cosine of f of x times the derivative of f of x is f prime of x. How about the derivative of y? Well, that's kind of like doing the derivative of f of x, right? Remember, we're doing the derivative with respect to x. So what's the derivative of y? Well, we usually just say y prime. How about the derivative of tangent of y? Well, because it's not tangent of x, it's tangent of y, and y is not x, y is a function, we need to do the chain rule here. The derivative of tangent is secant squared with the inside function left inside of it, times the derivative of the inside function, which is y prime. The derivative of x is 1. Notice the difference here. The derivative of y was y prime. The derivative of x is 1 because we're doing the derivative with respect to x. How about the derivative of xy? Well, this is a product. X is multiplying times y. So we're going to do the derivative of the first one, which is 1, times the second one left alone. Usually we would just write y here. But the derivative of the first times the second, plus we leave the first one alone, times the derivative of the second. But the derivative of y is not 1. The derivative of y is y prime, because we're doing the derivative with respect to x. And so here, it should be symmetric, but the derivative of x is 1, the derivative of y is y prime, and so we end up with y plus xy prime. We don't usually write the 1 there. The derivative of natural log of x? Well, the derivative of natural log of x is 1 over x. It's one of our memorized ones. What about the derivative of natural log of y? Well, now this is not an x on the inside, so we're going to need to do 1 over, leave the inside function alone. So it's 1 over, we leave the inside function alone, but then times the derivative of the inside function. And we almost always simplify this to be, we put this over 1 and multiply times the top, so we get y prime over y. The derivative of e to the x? E to the x. But the derivative of e to the y is e to the y times the derivative of the inside function, y prime. And so what we should have seen here is that when you do the derivative and it has a y in it, you're going to get a y prime. If you do the exact same thing and an x would give you a 1, the y will give you a y prime. So let's see how we use this idea that we can take derivatives of things with y in it. And first, we're going to do something a little bit ugly. Let's consider x squared plus y squared equals 25. And I hope we recognize this from Algebra 2. This is the equation of a circle. And in Algebra 2, very briefly, we almost always use this equation of the circle because it's easier to use than what I'm about to show you. But we did briefly say we could solve for y. We could get y by itself by subtracting x squared, so 25 minus x squared, and taking the square root of both sides. But we have to be careful here because when we take the square root of both sides, we need a plus or a minus. And so we actually end up with two formulas. Y equals the square root of 25 minus x squared. That's the top half, the top semicircle. And y equals negative square root of 25 minus x squared. So we can do the derivative of this. And the derivative, go ahead and do it. the derivative of this one is, we need to rewrite this as a power rule. This is a composite function. We have 25 minus x squared to the 1/2 power. That's what doing the square root is. And so it's going to be 1/2 times 25 minus x squared to the, we need to subtract 1, 1/2 minus 2 over 2. This is a fancy form of 1, is negative 1/2. So when we lower the power by 1, we get negative 1/2. With the inside function still left inside of it, times the derivative of the inside function. Be a little careful here. The derivative of 25 is 0, but this minus goes with the x squared. So the derivative of negative x squared is negative 2x. And this needs to be in parentheses to be multiplying, otherwise it looks like it's subtracting. So y prime equals, this goes to the denominator. This 2 is in the denominator. And so it's a negative exponent, and the root, it's going to be the square root. And this negative 2x can multiply times the numerator because we can do negative 2x over 1, and it'll be negative 2x like this. Now, this will cancel out. So this is the derivative formula for the top half of the circle. So y prime equals negative x over square root of 25 minus x squared. This could be a little bit faster if you know the derivative of the square root of x, that it's just 1 over 2 square root of x. It would have saved you a little bit of time, but it's still pretty ugly. And we only have done the top half. Now we need to do the derivative formula for the bottom half of the circle. Luckily, you know, if we think of this as f of x, then this is just a constant multiplier. And since we've just found the derivative of this, the derivative of this one will be the same as the derivative of this one, but times this constant multiplier. So we've already, like, if you think of this as like f of x, and this is f of x, the derivative of negative f of x is just negative f prime of x. And so it'll be negative, so negative of negative is a positive. So we get these two derivative formulas for, so we don't have to redo this. I mean, we could redo this and we'd get this, but this is the top, this is the slopes of the top half of the circle, and these are the slopes of the bottom. And it should make sense that they're the negative of each other, like the slope here compared to the slope here are opposites of each other, right? This one's positive whatever, this one's negative whatever. But we have a better way to find the derivative of stuff where it's like annoying to solve for y. Like this formula, we usually use this form, this implicit formula for y. By the way, let's make sure we understand what the word implicit versus explicit means. Explicit means you directly say something. So here we're directly saying y equals something. This is an implicit formula. We're not saying what y equals, but you can figure it out. Like if x is 3, I can do 3 squared plus y squared equals 25. This is 9. I subtract it on both sides. Y squared equals 16. And we do the square root on both sides, and we get y is plus or minus 4. So when x is 3, 1, 2, 3, the y is either positive 4 or negative 4. This is an implicit formula. It doesn't tell us directly what y is, whereas this one says, hey, y is the square root of 25 minus x squared, and y is negative the square root of 25 minus x squared. It directly tells us what y is equal to. It's explicit. An example would be like, a non-math example of using the words explicit and implicit would be like, let's say like some guy asks you out on a date, and you're like, you don't want to go on a date. Explicitly telling him would be like, no, I don't want to go on a date with you. Implicitly telling him would be like, no, I'm sorry, I'm busy that day. And then he starts to ask again, and he's like, well, how about next? And you interrupt him, and you say, no, I'm going to be busy that day too. And he's like, what? I didn't even say what day it was going to be. And you're like, yeah, but I'm going to be busy that day. Like, are you directly telling him you don't want to go on a date with him? No, but is it clear? Yes. So explicit is when you directly say it. Implicit is when you say it, but without saying it. So we can actually get the derivative implicitly. You don't need a formula, an explicit formula for y to be able to find the derivative. Because what you can do is if you have f of x equals g of x or whatever, you can just do the derivative of both sides. If the two functions are equal, the slopes will be equal. And so if we have x squared plus y squared, let's write this right here, equals 25. We can just do the derivative of the left side and do the derivative of the right side. And since these were equal, the slopes are going to be equal. Let's see. How do we do the derivative of the left side? Well, the derivative of x squared is 2x, and this is where things are a little, be careful and think back to up here. The derivative of y squared is, this is a chain rule thing because it's not an x. The derivative of y squared is 2y times the derivative of the inside function, which is y prime, equals, and this is something kids mess up sometimes, the derivative of the other side is 0. Don't put equals 25. You have to do the derivative of both sides. You can't do the derivative of just one side. And now, look, we can solve for y. We can move the 2x to the other side. 2y y prime equals negative 2x, because we had to subtract 2x on both sides. We can divide by 2y on both sides. And this is a lot simpler than this. The question is like, are they the same thing? And the answer is yes. If you plug in the explicit definition of what y is, like if you plug in square root of 25 minus x squared for y, you'll notice it will become this other formula. But you don't need to. You can just like leave it like this. So, determine the equation of the tangent line to the graph at x equals 3. Well, what are the things we need to be able to find the equation of a tangent line? We need a point, x1, y1, because we're going to do y equals, the equation is m times x minus x1 plus y1. We need a point, and we need a slope. So this is the slope, is y prime. So the point, when you plug in x equals 3, there's two different points. And I can find this either from the explicit formula, I can plug in 3 and get, so we've got 3, 4, and we've got 3, negative 4. There's two different points. And there's actually two different formulas for where the slopes are, depending on what point you're on, if we use the explicit formula. But let's see how it works using the implicit formula. To find the slope using the implicit formula, it'll usually have x's and y's in it. Well, you already had to find a point anyway, the point 3, 4, and we will need a point to find the formula implicitly. What we'll do is we'll just plug in the x and the y. And depending on which x and y you choose, you'll come up with a different slope. So when you plug in 3, 4, you'll get negative 3/4. If you were to plug in 3, negative 4, you would get y prime equals negative 3 divided by, if the y is negative 4, which is positive 3/4. So here is your point and your slope. There's actually two different points and slopes depending on which one of the points you want to pick at x equals 3. And the equation, of course, would be y equals 3/4. That would be if I'm doing this one, times x minus 3 minus 4. That's for this one. Or if I choose this point, it would be y equals, the slope would be negative 3/4 times x minus 3 plus 4, because I would use this point that goes with it. So with implicit formulas, you're oftentimes they'll be like, hey, at x equals 3, well, you're going to have to plug in x equals 3 back into the original formula to find what y was, so that you can plug in both x and y. So sometimes, like this, guys, I don't know if you can tell the difference between the amount of work required here versus the amount of work required here is like immense. This is way easier. And I was using some math tricks to skip a bunch of steps here. But there are also some problems where you cannot even solve for y. So, every once in a while, there's an equation like, x squared plus y equals 7. There's an equation like x squared plus y equals 7 where you're like, okay, well, y isn't by itself, so I could do this implicit formula, or I could just get y by itself first. And so every once in a while, it's easier to just solve for y when it doesn't start with y equals. But a lot of times what we'll do is we'll just do the implicit differentiation here, and we'll say, okay, we'll just do the derivative of the left side, 2x plus the derivative of y is y prime, equals the derivative of 7 is 0, and then we'll solve, and we'll get y prime equals negative 2x. It gets you the same answer. It's not actually that much slower, but every once in a while it's better to just solve for y. But if they're any sort of tricky things, like it's y squared or y times something, it'll almost never be better to solve for y. So let's see. Let's practice this sum. Find dy dx by implicit differentiation. So we want to find the derivative of y with respect to x, and go ahead and try this on your own. I'm gonna let you try all of these on your own, and if you need help, I'll come in to help you. So what we should see is when we do the derivative of the left side, so here it's not easy to solve for y, so we just don't because of this y squared. The derivative of the left side is, this is a chain rule thing. It's going to be 2 times the inside function times the derivative of that inside function, y prime. Whenever there's a y, you're going to end up with a y prime. The derivative of 2 is 0. The derivative of negative 3x to the fourth is negative 12x to the third. We're just doing the power rule, and here we don't have a chain rule because it's an x. Equals the derivative of 4x is 4. And what we're always going to do, oh man, this is blurry. Why is this blurry? No, I don't know why it's blurry. Okay, seems better now. What we're always going to do is whichever term has the y prime in it, we're going to get it by itself. So we're solving to try to get this term by itself. This is the same as if you have like 2x minus 12 equals 4. We're trying to get x by itself. We move the 12 to the other side. We'll move any terms that don't have a y prime to the other side. So 2y, y prime, equals 12x cubed plus 4. I could have put 4 plus 12x cubed. It's okay. I just added this to both sides. And then to get this by itself, we need to divide by 2y. And we get, we have to make sure when we divide the whole side. And we'll get y prime equals 12x cubed plus 4 over y. And that's it. That's how we leave it. We leave it like that because it's a formula for y prime. Now notice it has y in it. So if I wanted to find y prime at x equals 3, I would need to not just plug in x, but use x to go back into the original equation to find what y could be. And sometimes there's more than one answer. Like when you take the square root of both sides and it's positive or negative, well, you might end up with more than one slope that's possible. That's fine too. All right, on B, what is the derivative of this? Here, boy, you don't even know the derivative of arcsine yet, which is what you would need to get the explicit formula, but we'll learn it soon using implicit differentiation. Okay, so the derivative of both sides, the derivative of cosine is negative sine, the derivative of sine of y, the derivative of sine of something is cosine of that something times the derivative of the inside, which is y prime, equals the derivative of the other side is 6x. So we're going to take anything that doesn't have a y prime in it. So this is going to stay here, but anything that doesn't have a y prime needs to go to the other side. So we add sine of x. So cosine of y, y prime equals 6x plus sine of x. And then whatever's multiplying by y prime, we divide. I'm going to start using different colors. I feel like I should be doing that already, and I haven't been. And so y prime equals 6x plus sine of x over cosine of y. Okay. How about this next one? What is the derivative of y? Well, let's just do the derivative of both sides because it doesn't have y equals. If it's an implicit formula, you usually just do the derivative implicitly. The derivative of x squared is 2x. The derivative of y squared, we need the chain rule on because it's not just x squared. It'll be 2 times the inside function left alone times the derivative of the inside function, which is y prime, equals the derivative of 100 is 0. So we do the derivative of both sides. The thing that has the y prime, we're going to get by itself. And so we need to move every other term that isn't there, anything that has a plus or a minus, to the other side. So we're going to do minus 2x on both sides, and we will get 2y, y prime equals, I'm going to put negative 2x plus 100, but you could put 100 minus 2x, it would be fine. And then we're going to divide by 2y, because we want to get this by itself, and it's multiplying by 2y. And so we get y prime equals, here we can simplify a little bit. You'll notice they all have a multiple of 2, so we can divide by 2 over 2 and get just negative x plus 50 over y. Okay, this one is going to be a little bit different, and I think I'm going to walk through it with you rather than let you try it on your own. So sine of y plus y, we'll see why it's different. So the first part isn't different. You can do the first step yourself. What is the derivative of both sides? Well, we get, this is sine of something because it's not just an x, it's not just sine of x. So the derivative of sine of something is cosine of that thing times the derivative of the inside function. Plus, we've got something cubed, so we're going to use the chain rule. It's going to be 3 times that something squared times the derivative of the inside function, which is y prime. The derivative of cosine of x is negative sine of x, so negative sine is plus sine of x equals 0. And now what we should notice, the different thing here is there are 2 y primes. And so same as before, anything that doesn't have a y prime, we're going to move to the other side. So we're going to do minus sine of x on both sides. But the other thing there that we're going to do to be able to solve for y prime is if there's more than one of them, we just take all the terms that have y prime and factor out a y prime. We're going to factor out a y prime, and we're going to say it's y prime times whatever is left over. So y prime times cosine of y plus, so y prime times cosine of y gives us cosine of y prime, plus y prime times 3y squared will give us 3y squared y prime. So this is a way of rewriting it, but now there's only one y prime. So we get, if there's multiple y primes, and it's not just if there's 2, if there's like 5 y primes, you would just get all the things that have a y prime on the same side and factor out a y prime, and now there will only be one y prime. Remember, we moved the thing that doesn't have a y prime with it to the other side. And now that we've factored it out, it's pretty easy to get the y prime by itself. We just divide by what it's multiplying by. So this is multiplying by cosine of y plus 3y squared. And so that's what we divide by. And now y prime is by itself. So y prime equals negative sine of x over cosine of y plus 3y squared. That's it. So again, because this was new, if you end up with more than one term at the beginning that had a y in it, you'll end up with more than one y prime. And if you have more than one y prime, you get all the y primes on the same side. These already were on the same side, but like if the y cubed had been over here, we would need to move the y prime over to this side. And then you factor out the y prime. So now there's only one y prime, and you can divide and get the y prime by itself. Okay? This one's funny. Go ahead and try this one by yourself. If you do it implicitly, you should have gotten the derivative. This is a product rule. So we do the derivative of the first one. The derivative of x squared is 2x times the second one left alone, plus we leave the first one alone, times the derivative of the second, and the derivative of y is just y prime, equals 3. I want to point out here, I see sometimes people will mess up like the derivative of 3y, and they'll put like something weird. The derivative of x is just 1. The derivative of y is just y prime. Don't try to get into some product rule where it's like 3y, y prime. I sometimes see kids write crazy stuff. I don't know where it comes from. The derivative of 3y is 3y prime. The derivative of y is just y prime. And so now we can solve for y prime. We need to move this to the other side because it doesn't have a y prime in it. And so we get x squared y prime equals 3 minus 2xy. And we divide by x squared. And that's fine. I want to point out this is one that we actually could have done explicitly. It's pretty easy to just solve for y here. We divide by x squared. And when we divide by x squared, an x will cancel out from both of these. This is just 3 over x. And this is power rule. This is 3x to the negative 1 power. And so y prime equals negative 3x to the negative 2 power, which is negative 3 over x squared, which doesn't quite look like this, but it turns out is the same thing. Like if you were to solve for y and plug it in, it comes out the same. So, you know, kind of weird, but sometimes it's easier to just solve for y, kind of. Like this is a nicer formula. This would be fine. All right. Try this one on your own. Notice that there is 2 y's, so this is going to be one where you're going to end up with more than one y prime, and you're going to have to factor it out. So the derivative of sine of y, this is sine of something, so we need the chain rule, cosine of y times y prime. Here, this is a product rule. We're going to leave the first one, we're going to do the derivative of the first one, so the derivative of negative 4x is minus 4. Leave the second one alone, so we've got negative 4x times y squared, plus we leave the first one alone, so negative 4x times the derivative of y squared, which is going to give us a y prime. The derivative of y squared is 2 times y times the derivative of y, which was y prime, equals, remember to do the derivative of the other side, which is 0. So hopefully we got here that, I'll tell you, a common thing people miss is they mess up that the minus is with both of these. There should be a minus with both of these. Make sure you aren't missing that. When you end up with a product rule and there was a negative in front, the negative is going to end up with both. Okay, so I hope we noticed that this whole term is all multiplying together and it all has a y prime. This term has a y prime, but this one does not. And so we need to move this to the other side because it doesn't have a y prime. And these ones, well, I'll rewrite it. This is a little bit too messy. Oh, we could simplify 4x times 2y. This is 8xy. Sorry, that's ugly. 4x times 2y, we can multiply the 4 times the 2 to get 8. So 8xy, y prime, equals, we move this to the other side. And now we have 2 y primes, and so we factor out the y prime. Oh, sorry, cosine. This doesn't make any sense. You're not going to end up with cosine of y prime. Cosine of y prime. Yuck. Sorry, guys. This was I did a messy job of showing you this. So we're going to factor out the y prime from both of these, and what's left over is cosine of y minus 8xy equals 4y squared. And we're going to get y prime by itself. Y prime is multiplying by this, so we're going to divide. 4y squared over cosine of y minus 8xy. So there we go. There is y prime. Hopefully you feel okay about this. Let's look at how some of the multiple choice works on this. If x squared y minus 3x equals y cubed minus 3, then at the point negative 1, 2 dy dx equals, go ahead and try it on your own. And we'll see if you needed some help. Maybe you did. So y is not solved for, so we're going to do implicit differentiation. We're just going to do the derivative of both sides. Here, there is a product rule. These are multiplying, so we have to use the product rule. The derivative of x squared is 2x times the second one left alone. Plus, we leave the first one alone, times the derivative of the second, and the derivative of y is y prime. Okay, minus 3x, the derivative is minus 3, equals, the derivative of y cubed is 3 times y squared times the derivative of the inside function, which is y prime, and the derivative of negative 3 is 0. Here I've got 2 y primes, and I need to get them to the same side. I could move this to the other side, but then I'd have to move both of these to this side, and so it seems easier just to move this one to get it to the other side, so that all my y primes are on the same side. But if you did it the other way, you wouldn't get it wrong. You just end up with like a negative over a positive instead of a positive over a negative, basically. So we have 3y squared y prime minus x squared y prime. And because these both have a y prime, we can factor out the y prime. What's left over is 3y squared minus x squared. A lot of people will, at this point, just be like, okay, I know y prime, I'm just going to divide by these. So 2xy minus 3. People start skipping a lot of steps in this, and that's okay. 2xy minus 3, we need to divide by what was multiplying by y prime to get it by itself. 3y squared minus x squared. So now, this isn't the answer to the question. It asks us to find dy dx, which is what this is. This is dy dx, at the point negative 1, 2. So when x is negative 1, y is 2, in this formula, we can just plug in x and y. So 2, x is negative 1, it says. 2 times negative 1 times 2 minus 3 over 3 times y is 2. 2 squared minus x is negative 1 squared. Okay, so let's be careful about our multiplication. 2 times negative 1 is negative 2. Negative 2 times 2 is negative 4. Negative 4 minus 3 is negative 7. Here we have 2 squared is 4. 3 times 4 is 12. Negative 1 squared is positive 1, so it's minus positive 1, which is negative 7/11. And so we get A, negative 7/11. How about this? If y squared minus 2xy equals 16, then dy dx equals. I want to show you, well, okay. We're going to do this. Okay, let's see if you get it right, and if you don't, we'll see what's going on. Hopefully we see here we can do the derivative of both sides. The derivative of y squared, this is going to be a chain rule one. It's going to be 2y times the derivative of the inside, which is y prime. Here's a product rule. We have negative 2x is multiplying times y. The derivative of the first, the derivative of negative 2x is just negative 2 times y left alone. Plus, we leave the first one alone, negative 2x alone, times the derivative of y, which is y prime. Equals, on the other side, we have 0. We have two y primes here, so I'm going to move the thing that is not, this term does not have a y prime. And when I say terms, I mean things that are separated by pluses or minuses. That's what a single term is. So we get 2y prime minus 2xy prime equals 2y. We can factor out the y prime. So what's left over here is 2y minus 2x. And we can divide 2y over 2y minus 2x. And I should notice that they all have 2's in them. So I get y over y minus x. I can divide them all by 2. Now, when I look at my answers, I see y over y minus x. And boy, there it is, C. But I want to highlight something. Sometimes you end up getting, I want to show you another choice I could have made. What if I had chosen to bring the y's to the other side? What if I had chosen to do, like bring the y's to the left side and left, so I'm going to leave this alone. So negative 2y equals, and I'm going to move this to the other side by doing minus 2y y prime, and brought this to the other side by doing plus 2x y prime. And now I factor out the y. This is a legitimate choice I could have made. And divide. So negative 2y divided by negative 2y plus 2x equals y prime. And I can divide them both by 2 again. And now I'll get negative y over negative y plus x. And now I don't actually see any of the answers here. This doesn't quite match up. It doesn't have a y on the top. I know this is going to be wrong. There's no way this y can turn into an x. Here I've got y over x minus y, but this says negative y over x minus y. Now, negative y plus x is x minus y, but the top doesn't seem right. Here it's positive y, but I've got negative y and negative y plus x. Those don't seem the same. Here I've got a 2y, but not a 2x. These aren't the same. Here there's a 2y. These aren't the same. It turns out that sometimes there's a trick you need to do, which is that like if it's a multiple choice problem and you did it the other way from how they did it, you might need to take your answer and multiply by negative 1 over negative 1 to get the multiple choice answer. So y prime, we'll see if we get negative 1 over negative 1. You'll get positive y over positive y minus x. And there's that answer that we got before. This happens if you happen to bring something over to the other side of how they solved it. There's no reason you had to bring it over to one side versus the other, but you do need to be aware of this negative 1 over negative 1 trick. Guys, that's it for today. Your homework today is just to give you a taste of what like some courses around the country look like and some college courses look like, which is just like they give you a book and they give you like all these problems out of a book. And if you look at, oh man, I wish I had printed it out. If you look at your homework for tonight, it's just like a page from a book. And the way I'm going to grade it is it's 4 points per problem. So you can do 25 questions to get to 100, or you can do more. You can do like 40 questions and get to 160. I think that's the maximum I think the maximum I can put in teams is like 140. So you know, don't go more than 35 questions. Each part will be a question. So if you do like, if there's like 16A, 16B, 16C, 16D, each of these is worth 4 points. Also, you know, this is actually a good advent in the last few years. I think I put at the top of the page in your homework, there is rather than making a video for it, there is what is done a lot in these courses is there's like an online help thing. So you can go to like this website and click on what the homework was, and it'll walk you through some of the problems if you need them. Anyway, there's a lot of practice to do on this to get familiar with it, and it gets faster and faster. Like the problems start out taking a little while, and then once you get used to them, they start going really fast. Like honestly, all of the notes from today, like all of these problems from today, if I were doing them, I would have gotten done with them in like about 5 minutes. And you guys will get very fast at it too after a little while, because all the steps just start becoming automatic and very obvious. So I hope you get some good practice on this stuff. We have a test coming up next week, and I hope you have a good rest of your day.